Mr. Beverly, you're muted if you don't know.
Why did I get muted? Yeah, thanks for telling me that. Yeah, so that's why no one is answering my question. So we're looking at our first harmonic. So how many waves do we have in our first harmonic? So we have this. So yeah, our first harmonic is just going to be going back and forth with one wave envelope right here. We have our nodes that aren't moving. We have one antinode that's moving a lot, back and forth a whole lot of times. So like you said, we have half of a wavelength here. So I'm just going to do this by trial and error until I'm able to get that first harmonic. I'm going to be adding masses to my container down here until I get to the pattern. So we're adding nickels, trying to see this go into all right, so we see pretty good a first harmonic right here. So the endpoints aren't moving whatsoever. And then the other endpoint down here is not moving, and I just have this one antinode in the middle going back and forth. All right, so everyone can see how that's the first harmonic, or the fundamental harmonic. Now let's see how much mass we have here. So I have my container here, which I gave you the mass of that container is the same as the mass of 2 dimes and 1 nickel. And we'll count out how many nickels we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our mass is going to be 18 nickels plus the mass of the container, which what I just said was 1 nickel and 2 dimes. All right, so try to find the total mass. So what's the total mass that I have hanging off the edge there in order to get that first harmonic? And the dimes are 2.268 grams. Does everyone have a calculator? $99.536, let's see. Sounds about right. So 99.536. And what are the units? So we have 99.536 grams, but we obviously want this in kilograms, so let's put this into kilograms. All right, meters, kilograms, seconds. So we know 1,000 grams is equal to 1 kilogram. So how many kilograms? All right, so yeah, we're going to divide this by 1,000. So we have 0.099536 kilograms. But what is this mass hanging over the edge doing? What is that mass hanging over the edge doing to the string? All right, so it's causing a tension. So tension, we have that new equation. That's the speed of a wave on a string is equal to the square root of that tension times the length of the string divided by the mass of the string. All right, so we can use all this to figure out how fast that wave travels through our string. Now, the mass is just hanging there, staying at rest. So what can I say the weight of the container is equal to? Well, yeah, the weight is the force of gravity. And that force of gravity, if you meant that's equal to the tension, I think that's what you meant to say. So yeah, our tension and weight of the hanger are going to be the same. So I can find the weight of this hanging mass is going to be that. Let's write this big so everyone can see. So we have that 0.09956 kilograms times 9.8 meters per second squared in order to get our weight. And our weight is equal to the tension. I measured the string for you earlier. It's 53.5 centimeters. But how much is that in meters? .535 meters. So times the length of the string, 0.535 meters. And then the mass of the string, this was actually a giant pain to measure. But yeah, 4 times 10 to the negative fourth kilograms per meter. Well, I have kilograms per meter, and I have this many meters, so I have, what did I say? 4 times 10 to the negative fourth kilograms per meter. I have 0.535 meters. So this is going to be my mass of the string. So what's the mass of our string? should get something like 2.14 times 10 to the negative fourth kilograms is the mass of the string. Right, everyone see how I got that? Because I know how many kilograms there are per meter, so I can multiply by the number of meters to get the mass. So that I can put in for the mass of my string, so that 2.14 times 10 to the negative fourth kilograms. And let's be really careful to put this in parentheses when we put that in our calculator. So I'll give you a second to calculate that. Again, let's make sure we calculate it. A lot of times for strings, we're going to have, yeah, this is lab predictions. This is the very first part of lab predictions. So what do you mean we changed it? Yeah, so the hanger, so that's the hanger without anything in it. So that's this thing. So just the plastic container with the string holding up. So that's part of it. And then I was adding nickels into it. So I'm adding nickels to increase that hanging mass. So yeah, so the container itself was a mass of 1 nickel and 2 dimes, and I added 19 nickels inside of here. So I have to add both of these masses together. Is that what it ends up being? Yeah, 49.38. I mean, you really would round by doing significant figures. We know to the third decimal place for a significant figure so far. Honestly, out of all of my measurements, the mass density of this is the hardest. That's the worst measurement I made out of all of these. So if anything's going to be off, it's going to be the mass density being off for the string. So I'll just go with the speed of the wave in the string is 49.38 meters per second. Yeah, I'm not too concerned about that right now. I'm more concerned that you're able to do this math. All right, so we know the speed of the wave in the string now. What can I calculate from that? Or what should I calculate after that? Not necessarily from that. We already kind of set it up here. We know we have half of a wavelength. So yeah, we can solve for a wavelength. We know we have half of a wavelength for the first harmonic. And that's going to be equal to the length of the string. So I know half of that first harmonic wavelength is going to equal the length of the string is that 0.535 meters. So what's the wavelength of our first harmonic? .5 times 2 is 1. 35 times 2 is 70. Not 0.66, because that should be 70, but you still have a 0 here, so it should get 1.07 meters, yeah. I think you did 1.5 or 0.533 times 2. All right. So now I have my wavelength, I have my speed. So wavelength is one of the things I wanted you to predict. The other thing was frequency. So now we can just use our wave equation. Speed is wavelength times frequency. So frequency of that first harmonic is going to be the speed divided by the wavelength of the first harmonic. So we got 49.38 meters per second. And we had a wavelength of 1.07 meters. So our first harmonic frequency is sounds about right. 46.15 hertz. All right, now when we look back to this last class, remember how we kind of figured out that relationship, how I could do frequency of the nth harmonic is n times this number. So we could do frequency of the second harmonic would be 2 times this. So we can do that as long as I'm not changing anything about the string itself. But the problem with my setup is I just have a set DC motor that only spins at a certain rate. So the motor is always going to put out the same frequency. So what we're going to see here is we're actually going to have a constant frequency for all of these because I'm keeping the same motor for all of these. So the frequency of all my harmonics I do here are just going to be this 46.15 hertz. That's just kind of a limitation of the setup I have. So now I want you to make your predictions for the second harmonic. So start by trying to draw out that second harmonic and know the frequency for the second harmonic is going to equal the frequency for that first harmonic. Just because the motor is what's controlling the frequency, this thing right here spins at a set rate no matter what, so it puts out a set frequency no matter what. So I'll give you a few minutes. Yeah, you can use Google Docs for the lab predictions. That's why I uploaded it as, I think I put it as a PDF and a Word document. So if you want, you can just open up the Word document and edit it from there. That's perfectly fine. It just might be hard to draw it out. I don't think I asked you to draw anything out though, so. So we do know our frequency is going to stay the exact same due to a limitation. Predictions, ask for force of tension and wavelength. Is that all you want us to write? So if you do write it on the Google document, at least I guess I would like a picture of your work. That would be nice for me to see a picture of your scratch work. So yeah, I guess I do want you to draw a picture out and just take a picture of it. That part doesn't have to be super like formal or anything. But yeah, that would be good. So I'll give you about until 10:40. Try to draw out your second harmonic. try to think about what would be changing. You can probably get your wavelength first. You can type up the work. That'll probably be a little bit harder than just writing the work on a scratch paper and just putting your final answer in the document. But you can do that if you're fast at that. So again, try to draw that second harmonic. Try to get your wavelength for the second harmonic. Once you have your wavelength and you know your frequency, you can get the speed. And once you know the speed of that wave, you can try to calculate the tension. Yeah, Google Docs might be being weird because this is a Word document. I know sometimes they don't play nice with each other. What's the mass for the, are you talking about the string mass? The string is going to have the same mass as before. The hanging mass will have to be different though. So that's what we're going to end up adjusting, is how much mass we put in the container. So you're trying to, yeah, so how many nickels would you have to add? I think it's more than just one, if I remember correctly. So yeah, how many waves do we have for that second harmonic? And what else do we call the second harmonic? So how many waves do we have for the second harmonic? And what's the other thing we can call the second harmonic? All right, so we can call this our first overtone. So this is the first frequency this is going to resonate at. Well, for here is speed. So this is the first overtone. And so here we're going to see one full wavelength, right? Each time we're adding a half wavelength. So we had a half wavelength before. We added a half wavelength, so we're going to see two half wavelengths here. Goes like this. Yeah, Google Services, I think Google Services is just overloaded with everyone using it. So yeah, if you're having any difficulty with turning things in on Google Classroom or having difficulty using Google Services, you might try to use them later or earlier, like before 7 or 8 or after 6 or 7. It might work a little bit better, but yeah, I'm pretty sure it's just a little bit overwhelmed. Yeah, it might be if you do have access to a printer that you can use, that might be useful. I'm not going to require people to do that because not everyone has a reliable printer. So I have 3 nodes, I have 2 antinodes. Yeah, libraries. I feel like a lot of libraries are probably closed at the moment, though. All right, so I have 2 half wavelengths. So I have 1 full wavelength is equal to the length of the string. I still have 0.535 meter long string. Yeah, I mean, even if one person prints it and does the work, if everyone's kind of collaborating, you can all get onto Google Meets. I'm pretty sure you can make one. All you have to do is go, and then the button you hit for when you go to the Google Meets, you just hit start and you just type in your own whatever you want to call it, and it gives you a code. So if you do that and you share it, then other people are working and you're writing on a paper. That could be a way of doing it. All right, so this is the easiest one to get the wavelength for. Wavelength is 0.535 meters. So what can I get from frequency and wavelength? All right, so we can get the speed of the wave on this string. So we're going to see what we're doing is adjusting the speed of the wave for this setup. So 5 meters. Yeah, the frequency I'm using is from the first. And again, the reason we have the exact same frequency is, again, the thing that controls the frequency is this motor. I could probably short out some of the batteries and send a lower voltage to change the amount that the motor rotates at, or add resistors or things. I was thinking of doing that, but it would be a lot messier to do and a lot harder to handle that, especially since y'all don't have the math behind that. So yeah, we just have a constant frequency motor. So this motor is going to put out the same frequency no matter what we do. And so the frequency for the first harmonic is going to be the frequency for every single harmonic we do today. So the ones in class that we were doing, how we were getting different frequencies, we were keeping the same tension on all of them, which meant that we weren't changing anything about the speed of the wave. So here, instead of the homework you had, we were changing the frequency to get different harmonics. Here we're changing the tension on the string, which changes the speed of the wave through the string to adjust the harmonics. So yeah, every single one of these will have the same frequency. All right, so how fast does our wave travel? .69 meters per second. And we should see we half the wavelength, but kept our frequency the same. So we are going to have half the speed of the first harmonic. All right, now I know the speed of the wave. Now we're ultimately trying to predict our tension. So the speed of the wave is going to equal our force of tension times the length of the string divided by the mass. So what's the first thing I should probably do in order to try to get mass, or the tension, I mean? And again, we should probably, this is length of the string and mass of the string in this equation here. Well, the first thing I want to do is probably get rid of the square root. So I should probably square both sides, right? So we get speed squared is equal to tension times the length of the string divided by the mass of the string. We're trying to get tension, so let's probably multiply mass, divide length over. So speed squared divided by length of the string times the mass of the string is all equal to tension. And then we can just substitute our values in. Tension, our speed we just got was at 24.69 meters per second. Squared. The string has a mass of that 2.14 times 10 to the negative 4 kilograms. I did not change how much string I have here, right? I still have that same length of string. I didn't adjust anything about the length. So I didn't adjust anything about the mass of the string. And then this is all divided by that 0.535 meters length of string. So solve for the force of tension and then figure out how much I would have to add to my hanger to accomplish that. Is it 0.244? Let me check. So 0.244 newtons is my tension. And I know my tension is equal to my weight, which is equal to mg. 0.244 newtons is equal to hanging mass times 9.8 meters per second squared. Could I shift the papers? How? Like that? All right, so we have hanging mass is 0.025 kilograms. let's multiply this by 1,000 to put it into grams. So 25 grams. Everything is reversed for me. I have no idea which way you're trying to tell me to move this because here, let me look at my actual laptop. Is this what you mean? So you can have your chat box up? There we go. I think that's what you mean. Yeah, again, I think they designed this app so they're expecting you to like look at your face, and so they mirror your image like you're looking in a mirror. But when I'm looking through the other camera, it flips the screen over, so everything is like flipped horizontally on my paper, and it is really obnoxious. And so that I have it up on my laptop to the side so I can actually see it. No, I don't. I'm not writing all this backwards. It's just as I write it, I see it moving backwards on the screen. My camera is not upside down. I just looked it up. It's a feature of Google Meet, which I would say is something they should allow you to turn off, but it's not. Trust me, I've tried. I've just accepted it and have tried to get used to it. All right, so we have 25 grams is hanging. Well, I know part of that is going to be the hanger, right? Mass of the hanger itself is going to be the 1 nickel is 5 grams, and the 2 dimes is going to be 2 times 2.268 grams. So this much is taken up by the hanger. Which is so this much is taken up by the hanger, and I need to add some value in order to get this to equal that 25 grams. So plus some unknown value. So what could I add in order to get that to 25 grams? Like what denominations? Like how many nickels, how many dimes? I actually don't have any half dollars on me. So it needs to be in terms of nickels, dimes, and I guess you could use quarters and pennies. So you need to add 15.464 grams. Right, we know the mass of a nickel is 5 grams. Mass of a dime, 2.268 grams. Six pennies, but that should be equal to 3 nickels, right? So it's not a perfect amount. Let's try that. 1, 2, 3 nickels. Does 7 dimes work better? Seven dimes is close. It's kind of on the other word. Let's test it. Moment of truth. So yeah, really close. It's kind of going back and forth a little bit, so it's not perfect like we see our number is slightly off. So that's with 3 nickels added. We see a pretty clear second harmonic. Let's try with 7 dimes. See if that's a little bit closer. Yeah, 7 dimes is a little bit too heavy. You can see it trying to do it, but it's a little bit too heavy. But yeah, so it's somewhere right in between those values. And I guess the cat is scared of that noise and went running. All right. So we were pretty much right on. And that's honestly my favorite part of physics, when you don't test something and you just do the math and then it works out. All right, so now try to do the third harmonic. And I'm not going to go through all of the work for you on this one. So I'll give you about 10 minutes to do this until about 11:10. I'll answer questions as you go through it, but I'm not planning on walking you through each individual step. Trying to finish the first one. What do you mean the first one? Like the first harmonic? You don't have to actually finish the lab right now, though. So right now, focus more on getting the data and making the predictions as opposed to making it look really nice. You can always look back to the video. I'll upload the video. It'll be on YouTube in about an hour after the class ends. Well, we already did the predictions for the first and second harmonic. So right now you should be trying to do the prediction for the third harmonic. So was that like 89 or something? Linear mass density, you multiply it by the string length, but again, the string is the same exact length in all of these. So we're going to get the same mass of string. Is always going to be that 2.14 times 10 to the negative 4th kilograms. So each harmonic, you add half a wavelength. Yeah, the closest I've ever gotten to getting a viral student. Yeah, AP students, it's probably like a quarter of people there during class, but more people after. Are you talking about how many watched the dual credit class? I haven't seen anyone in here from AP today. A few people were jumping at me. Someone broke into your car. Hopefully not too bad. Yeah, I think by the end, there's a lot more views. It's also hard to tell because I think a lot of people open, close, and it counts those all as individual views. So it's hard to tell. Uh, it didn't seem like she was joking. So we added half a wavelength, so I will draw this out. How many waves do I have now then? If I had half a wavelength for each harmonic, so I have my third harmonic, 3 half wavelengths. Three. So I have 3 half wavelengths is equal to the length of the string. We can use this to get our wavelength. We know our frequency is staying constant, which I forgot what that value was, 46.15 hertz. Once we get our wavelength and frequency, we can find the speed of the wave on the string. Yeah, frequency again is staying constant for all of these because the frequency is set by my little motor I have spinning this. It will change slightly over time due to the batteries getting used. And that's what question 7 is asking you about. So we can get our speed. And then once we get our speed is the square root of tension times length of the string divided by mass of the string. So we use that to get our tension, but we know tension is equal to the hanging weight, I mean. Then we have that hanging mass is equal to mass of the hanger, that little plastic container, plus the mass of the coins. So ask questions if you have them, because I'm not going through all of them. Your work, is it messier than mine? Yeah, if you're trying to do it on Google Docs, it's probably not going to look the greatest. Yeah, as long as it's easy for me to follow, I'm fine. That's not good. Yeah, you should probably turn that off. Yeah, just shut the door and stay away. Yeah, I'll just keep the stream running all day and you just sit here and just say, I'm still in physics all day. Yeah, so you're not able to like see what the person looked like or any car. Yeah, that's most security cameras look like that. That's fine. I'm trying to give you time to work on this before we test it. But yeah, if anyone has any questions about any of the harmonics, ask them now because I want you to try to do all for the third harmonic. I'm not planning on going through this like I did for the second one. So if you have specific questions, please ask them. I'd be impressed if you could do the 200 word per minute with all of the variables you're trying to type things in with the math. Yeah, I was about to say the numbers at the top and trying to do the special characters like the square. Yeah, the symbols. Yeah, if you're able to type math equations at 120 word per minute, that's crazy. If anyone's getting stuck anywhere, just say something and I can help you. Or are people getting to the answer? I guess at least say you're at the answer. Can I go back to the second harmonic? So yeah, we're just doing the exact same thing again. Pretty much all of these questions for standing waves, we're normally going to be starting by wanting to draw this out. When we draw this out, we figure out how many half wavelengths we have. We can use that to get the length of the string and the wavelength. And then once we get our wavelength, we know our frequency is the same for all of these, so we can use our wavelength and frequency to get the speed that we want to achieve on the wave. And then once I get the speed of the wave, then we can use our FML equation in order to get the tension on the string. The tension is going to be equal to the weight of the hanging mass because the mass just hangs there at rest. So we can figure out the hanging mass. Once we get our hanging mass, then we can just do a little bit of addition and subtraction to try to figure out how much mass we actually need to hang, so we can figure out how many coins we need to add. Yes, we use that this formula here to figure out our tension. So once you figure out your wavelength from your picture and the length of the string, you can multiply that by frequency. Use this, we can solve for tension. I mean, if you can do that neatly, that's all right. So ultimately, tension is all I asked for on here. So if you get to at least the tension, that's good. The rest of this is just more so I can figure out how much mass I need to hang. Yeah, the tension is equal to mg. So I can find out how much mass to get. And then once you find out how much mass you have, then it's a matter of figuring out, well, my hanger has a certain mass, like 9 point something. And then so how much mass do we need to add to that? Yeah, and then in the end, try to figure out how many dimes and nickels I need to add. Five minutes. All right. I'm not actually going to test it until someone gives me a prediction for the mass. So can you have a hint for the answer? If you look back to the very beginning of the video, you already saw the answer. What's that? It's going to be a pretty small number. How small are you getting? Shouldn't be that small, I don't think. Yeah, not 0.66 grams. Yeah, it's a lot closer to 11 grams, somewhere around there. I got, my mass I just got was, what was that? Why am I up by a factor of 10? Yeah, like 10.8 grams, somewhere around there. Yeah, it should be somewhere around there, somewhere right around 11 grams. And what's the mass of the container? Thirty-six point one five. Yeah, let me check that again. Squared times 10 to the negative 4. Yeah, closer to. That's what I didn't do. 11.1 grams, somewhere in there, if you don't round. And what's the mass of our container? Two dimes and a nickel. It's pretty close. The container is a mass of 9.54 grams, about. Yeah, the tension is 0.108, yes. 0.108 newtons. And then you have to divide that by 9.8 in order to get the mass. So what we're seeing is pretty much all I need to do is put the container on, which is why I said if you saw at the very beginning, we kind of cheated because just the container itself is enough to get that third harmonic. So I have 1, 2, 3. Now it's not the best. You can actually see it going up and down. It gets wider and then less wide, which means we're not perfectly on the number. Like we saw the difference between 11 and 9.5. So we're really close to the number, but not exactly on it, which is why it's not staying perfectly steady. But yeah, really close there. All right, and then you're going to predict the fourth harmonic. What's the problem with the fourth harmonic? What's been happening to our masses we need each time? Yeah, 0.011 kilograms is 11 grams, yes. So we've been needing more or less mass each time? So we've been needing less mass. This is the mass of the container. So we can try to get our fourth. Let's see. We'll probably figure that out pretty fast. It's going to be a pretty small number. Let's see if I can do that. 6.5 times. So we get it's pretty much just above the mass of the nickel. So I might be able to just do that by bending this. There we go. So if I get a nickel just hanging there, let's see, that should be right around the fourth harmonic. And not quite. And it fell off. But yeah, the fourth is going to be pretty hard to get. You would need a really small mass to do that, and that's kind of hard to do. All right, so any questions on any of the steps here? I was kind of planning on doing this over 2 classes. So the evaluation of data, number 6, that very last question doesn't quite make sense because I was planning on doing this a second day. So you don't have to do that very last number 6. Yeah, it would be nicer. Also, the setups we have at school, you can adjust the frequency. I thought briefly about building a variable mass, like a variable resistor to do this, but that would be kind of more of a pain. And so, yeah, we ended up just doing this. So, yeah, it's been about an hour and a half. Anyone have any last minute questions on the lab itself? Yeah, so just finish your predictions, and we already did the tests, so also fill in your data. So we've pretty much done enough for you to finish the lab. I was planning on making it take 2 classes, but then I kind of realized it was probably going to go faster than that. So yeah, we've done pretty much everything we need for this lab. Next class, we will have a really quick smaller lab, which is the one where you'll be going through and using your bottles that you're collecting. So we'll do a real quick find the speed of sound and air lab with that next class. Next class is on a Monday, yes. So next class is on a Monday, and I'm planning on having the test on Wednesday at the moment. And your review is up. I'm going to post the answers to the review at some point. Yeah, your test is Wednesday. I'm probably going to post the answers to the review maybe on Monday. So you can start working on that. It will be a grade. Yeah, so the test is only going to be 4 free response questions. It's kind of shortened down. We've covered everything we need to cover for it. Again, the things I'm going to ask on it. Yeah, no stream that day. I'm not planning on doing that because I'm probably going to be worrying about grading then. Actually, no, I take that back. I am going to do a short stream that day, mostly just because the system I have for randomizing the test might be a bit confusing to some people. So yeah, tune in on Wednesday still, because I'll go through how to do the different questions, because it might seem confusing unless I work through them with you. Um, is what due on Wednesday? So the review is going to be due on Wednesday, if that's what you're asking. The test itself, it's really difficult to say like only tune in for a set time, because I know people have a lot of other classes. So it's just going to be you have Wednesday to finish the test. But after Wednesday, it's not going to be any time for late assignments or anything. You just have all of Wednesday to finish it, and then that'll be it. How many bottles? You need at least one bottle. If you're in MST, I'm thinking try to hold on to more than one bottle. But you just need one bottle that you're able to blow across the top and make it resonate loudly, like something like that. So you're going to be filling up the bottle and using a tuning app, and you're going to create a graph that you can use to measure the speed of sound in air. I mean, this is just a soda bottle. I mean, switch camera. So you like just do it a few times. So it's kind of across the top, but a little bit of the air should be going down into it. You don't need to cut it or anything, no. So yeah, just a normal bottle. Yeah, we're going to be changing the length of it just by adding water to it. So don't need scissors, don't need anything, just any sort of bottle, water bottle, Coke bottle, anything that you can use to resonate with that sound. Yeah, you should be able to use a glass bottle. That should be fine. Could you use a like a didgeridoo? Like, what is that? I mean, if you have an actual instrument, like a wind instrument, you could use that. If you have a recorder, I guess you could use that. But yeah, if you have an actual instrument, I guess yeah, you could actually use that. I do. It does need to be a wind instrument, though. It cannot be a stringed instrument. If you have a recorder, sure, you could use a recorder. You can use a clarinet. Um, yeah, you're going to have to do a little bit of a clarinet. Might be difficult because you're going to change length. It's going to be a little bit more difficult to use an instrument. A piano, you cannot use a piano. If you had a pipe organ, you could use that, but it needs to be something that uses air, wind. No, it can't. I don't want any sort of like keyboard or anything, because a keyboard is simulating everything. And then rounding to 2.2675, that should be fine. So I think that's most of the questions. I'm going to stop this stream. Just pretty much a few things to kind of be thinking about. Make sure you're gathering up a plastic bottle. Yeah, don't do question 6 on the 3rd page of the lab. A kazoo would be a little bit difficult. Yeah, you can't change the length of a kazoo. So not a kazoo. But yeah, make sure you're gathering up a plastic bottle so you can have that. Again, test next Wednesday. Post the answers to the review probably tomorrow. finish up the lab by the next day. Try to work in groups. Again, with your group member evaluation, a 5 is good. 5 means everyone did their work. If someone does 10, that means they did way more than they had to. They pretty much did all the work, and other people should have zeros. But a good group should have mostly 5s. Try to collaborate either through text or phone call, or yeah, you should not have a 10. You should not be putting 10 for your group member self-evaluation unless like that person did everything. 5s are good. 5, yeah, if everyone did an equal share of work, everyone gets a 5. So an ideal group should have all 5s. Uh, yeah. So it's kind of a thing. So if everyone kind of has someone at a 0 or a really low grade, I'm going to put a lower grade for them. And you'd be surprised how often people are honest. So if someone does less work, if someone does more work, that would be like a 6 or a 7. And if someone does less work, that person would have like a 3 or a 4. Yeah, it should kind of balance out. So if someone does 8, they did a lot more work than anyone else. That means other people should be down some. I mean, it really should average to about 5. I mean, if you have 4 group members, it should be about 20 total points. Yeah. 3 group members should be about 15 points. 2 group members should be about 10 points. And all right. And then, yeah, we will still have a tutorial tomorrow afternoon. So I forget the exact time. It's either 1 or 2. I forget what I said. I'll post that in the morning. And this will go up on YouTube pretty soon. If you still have questions, stick around. I can answer those for a little bit. Otherwise, everyone who's watching the video, have a good day.